Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the ACT. We have been solving ACT math problems out of this book here, the official ACT prep guide. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we're about to solve are the ones that you will find on page number 317. Please turn to it. Page number 317, and today is our lesson number 37. The very first problem that we're going to do today is problem number 53. Well, actually I keep saying very first problem. There are only two problems on that page, page 53 and 54. So 53 is what we're going to do first, obviously. 53, problem number 53 is the exact same problem, if you recall, that we did yesterday. The difference between the solution that we're going to present today and what we did yesterday is that yesterday, on day number 36, the way we solved problem number 37 was through a very classical, very orthodox, very conventional, very traditional way by using a formula. Now most people have trouble remembering this formula for arithmetic series, including myself. So today we're going to do the same problem but without the formula. We're going to do it in a little bit unconventional way. So here it is. A little bit of an untraditional way, not the kind of way that your math teacher would like you to do, but it doesn't matter, you just want to get the answer and that's all it is. So in a sense we're going to cheat the system a little bit. We're going to do it, as I said, without the formula. So here's what we're told here. We are told that we made 24 calls on first day. And then after that we made 5 more calls each day after the first. The question simply is, what's the sum of the calls? How many calls did we make in 20 days? If we made 24 calls on the first day, on the second day we made 29 calls, 5 more than before, and so on and so forth. So here's our, so on the first day we made 24 calls, on the next day we made 24 plus 5 calls, on the day after we made 24 plus 10 calls. This, whatever the number of calls that we made the day before, we made 5 more than that. So if this was 24 plus 5, this is 24 plus 10, 24 plus 15, and so on and so forth. Stay with me in this story, okay? Here's what we're going to do. Instead of using the formula, we're going to actually add up all of these numbers. We're going to simply add up all of these numbers manually. But there is a difference. Listen very carefully. There is a difference. There is a difference between adding up these 20 numbers through brute force, manually actually adding them up, as opposed to adding, we are still going to add them up, as opposed to adding them up by using some sort of a technique, some sort of a strategy, some sort of a trick. As long as you have some sort of a strategy, as long as you have some sort of a technique, and you're not just using a brute force, you're okay. Because adding up these 20 numbers by brute force, obviously, it's not what we're going to do here. It will take inordinate amount of time. It will take excessive amount of time. You understand? That will take too much amount of time. It will take inordinate amount of time. It will take too much time if we were to add them up. So here's what we're going to do. Okay, listen carefully. This 24 is same as 24 plus 0, isn't it? So here's our 0, then a 5, then a 10, and then 15, and so on and so forth. And at the end, listen carefully, and at the end we're going to come back, and pick up all of these 24s. All of these 24s will come back and pick them up at the end. Right now we're not going to worry about them. Which is very simple because we have 20 numbers and each one of them is 24 plus something. So it's just 24 times 20 is the sum of these 24s. 24, 1, 24, 2, 3, 4, and there are 20 of them. So the sum of these 24 is going to be simply 24 times 20 because we have 20 numbers. So that makes our life easy because now we do not have to add up 24 plus 29 plus 34 and so forth. We just have to add up 0 plus 5 plus 10 plus 15 and so forth. And finally 20. We're going to add them up. We're going to add them up 5 at a time. We're going to add up 5 at a time. And I need the room, so I'm going to start a little bit back here. Or we can probably continue here while I raise it. So let's add up these numbers. Enough of the talk, let's add them up. So what do we get here? 5 plus 10, 15 plus 5 is 20, 20 plus 10 is 30, 30 plus 20 is 50. So we get 50. Let's add up next 5, shall we? Let's add up the next 5. We're going to add up 5 at a time. The next one, this one ends at 20, so the sixth one is going to be 25, and then 25, and then 30, and then 30, and then 30, 35, and then 40, and 45. Now here's what you have to pay attention. Here is what you have to be smart about it. You have to see the pattern. You have to be attentive enough to see if there is a pattern that emerges here. Do you see a pattern here? This is 20. This is 25. It's 25 more. Why is it 25 more? Because by the time we get to the fifth one, each time we're adding 5, 5, 5, 5, 5. This one is going to be 25 more than this guy because this is the first one. This is the sixth one. This is the first term. This is the sixth term. So we have 5 5s in here. Each one of them is going to be 25 more. You see, 5 and 30. This 30 is 25 more than that. 35 is 25 more than that. So what do you suppose sum? What do you suppose sum is? What do you suppose going to be this? What do you suppose is going to be the sum? What do you suppose is going to be the sum of these 5 numbers? We know how to add them up actually. The sum of these 5 numbers is going to be same as that number right here, 50, plus 5 times 25. Why 5 times 25? Because each one of them is 25 more. There are, see, in other words, this is 5 plus 25, this is 10 plus 25, this is 15, this is, excuse me. The very first one is same as this guy. You see 0 is 0 plus 25, then we have 5 plus 25, then we have 10 plus 25, then we have 15 plus 25, and finally we have 20 plus 25. That's how we got 45. So we have this 20, 15, 10, 5 and 0. We know the sum of those is 50. And then we have 5, 25. 1, 2, 3, 4, 5. That's how we got 5 times 25. 5 times 25. 5 times 25 is 125 plus 50 is 175. And this one was 50. Remember, this one was 50. Let's keep on going. We're going to pick up a speed a little bit because otherwise it will get to be too boring. The next one is we stopped at 45, so it's going to be 50, 55, 60, 65, and 70. Again, you should immediately see this 50 is 25 more than that. So the sum of these 5 is going to be simply sum of these 5 numbers. Sum of these 5 numbers is simply going to be same as that number 175 plus 5 times 25. Because there are 25s in here, 5 25s in here. This 50 is 25 more than 25. Do you see that the difference is 25 each time? That's it. Let's do one more. 75, 80, 85, 90, and 95. Again, same exact thing. There are 25 more. They're all going to be 25 more because this is the 5th term, this is the 6th term, this is the 11th term, this is the 16th term, and so on and so forth. So we never finished this thing here. 5 times 25 is 125. 125 plus 175 is going to be 300. So this guy is going to be 300 plus 5 times 25. That's it, we're done. Let's add them up. How much is 5 times 25? It is 125. 125 plus 300. 125 plus 300 is 425. And let's add them up. 5 plus 5 is 0. Carry 1. 5 plus 5 is 10. Carry 1. We have 2 plus 1 is 3. 3 plus 7 is 10. One more time. 2 plus 1 is 3. 3 plus 7 is 10. 10 plus 5 is 15. Carry 1. We have 1 plus 1 is 2. 2 plus 3 is 5. 5 plus 4 is 9. 9. And don't forget, this is not the sum. We also have to add 24. We also have to add 20 24s. 20 24s, each one of them. You see, we left out the 24s. We left out the 24 here, 24 here. Each one of them we have left out 24 because 24 is where the series began. So to it we have to add. So final answer is 950 plus 20 times 24. Or better yet, we can just write it underneath here, so we don't have to rewrite everything. 20 times 24 is equal to 480, and that's our final answer. That's it. That's your sum of the series. So it's 0. 5 plus 8 is 13, carry 1, we get 14. Now as you can see, this is not quite as beautiful, this is not quite as elegant as using the formula, the conventional method. But conventional form method may be convenient, may be elegant, may be faster. But what do you do if you don't know the formula? So if the choice is between not doing the problem at all or doing it this way, well, it's better to do something than just not doing it at all. It doesn't take actually that long. Try it out yourself. Once you understand the concept, it doesn't take long. Of course, it always takes much longer because we are explaining everything here, but it's very straightforward once you understand the concept. Let's do the next one on the page, number 54. That's it, we are done with this one. Give me a second, give me a break a little bit. Number 54. Number 54 deals with a notion, a concept, what is known as piecewise functions. And if you do not know what a piecewise function is, or if you do know it, but if you need to get some more practice on it, if you want to get a little bit more familiar with it, then what I would like you to do is type in this tag, type in piecewise functions, and with my name here. Type in piecewise function and then Keshwani. Anytime that you're interested in learning any mathematical concept, type in the name of the concept and along with my name and see if something pops up. Most likely something will come up. Do you understand? There are close to 2,000 videos on there at my channel. There has to be something on a given subject. And if there isn't any, so be it. And at least you try it out. You understand? The question is this. This problem, number 54, deals with the notion what is known as piecewise function. It is also known as some people refer to it as discrete functions. Discrete function. Let's see what we're dealing with here. A piecewise function is so called because it comes in bits and pieces. It's not a continuous function. A discrete function as opposed to a continuous function. It has breaks in it. It is choppy. It does not flow continuously. Discrete function. Do not confuse this word discrete with this word right here. Discrete. Those are two different words, as we already learned a long time ago in our vocabulary lesson. On day number 8 in our vocabulary lesson, we learned the word discrete. They are homonym. They are pronounced in the same way, but they have different meaning obviously. Discrete as in discrete function, and discrete as in to be discrete, to exercise discretion, to not go around flapping your mouth, to flapping your gums rather. To not go around flapping your gums is called exercising discretion. It's called being discreet. Being discrete. Do you understand? So it is a piecewise function. It is a piecewise function because it does not come in a one continuous bit, but in this case here, it came in 3 pieces. It doesn't have to be 3 pieces. It could be 2 pieces. It could be 50,000 pieces. We are dealing with 3 pieces, and each piece will have its own equation. Each piece will have its own expression as to how what the value of the function is going to be. It's going to be determined by the expression that is given to us for these 3 distinct pieces, 3 separate pieces. The very first one is x squared minus 2. We are told that this function is going to be equal to x squared minus 2 when x is less than or equal to 1. If we are told that the value of the y is going to be x minus 7, value of the y is going to be x minus 7 because this is the value of the y. Value of the y is going to be x minus 7 if it turns out that x is between 1 and 5. And the value of the y is going to be 4 minus x when x happens to be more than or equal to 5. These are the 3 pieces we are dealing with. These are the 3 pieces we are dealing with. Now before we go any further, I want to make sure that you understand, I use the word when. In the book they do not say when, they say, I just noticed that in the book they say for. You can use when, or we can use if, or we can use for. It doesn't matter. It doesn't matter. And sometimes they don't use any words at all, and they just give you semicolon. There are no words there at all, it will just be a semicolon, but it's the same idea. So our job is to figure out which of these functions that are given to us depicts these three relationships for the three segments of the function. Three pieces of the function. Let's find out, shall we? The easiest and the simplest way, not just in this case, but any time if you're given different functions there on the piece of paper, if you're given different graph, and somebody tells you that I have this equation here, this equation pertains to which one of these 5 graphs, or which one of these 4 graphs, the easiest and the simplest way always is to locate the intercept. Find out where is supposed to cut the x-axis and the y-axis. And you will find out that, and you will see that in most cases, you'll be able to chop down, you'll be able to knock out at least 2 or 3 answer choices. In most cases, you'll be able to get rid of at least 2 answer choices just by looking at the place where the graph is supposed to cut the x-axis and where it's supposed to cut the y-axis. Do you understand? So let's do that. Let's look at the y-intercept. So here's our solution. Let's look at the y-intercept first. Before we do anything at all, let's look at y-intercept. Y-intercept means the place where the graph cuts the y-axis. For the place where the graph cuts the y-axis, if the place where the graph cuts your y-axis, that's where x is equal to 0. The question is, when x is equal to 0, what's the value of y? That's what we are trying to figure out. What is the coordinate of this point? What's the coordinate of this point where it cuts the y-axis? Well, where it cuts the y-axis, the x coordinate has to be 0. Question is, what's the y coordinate? So we're going to find out the y coordinate by substituting 0 in the function. So that is x-intercept first, that is when x is equal to 0. Now here we're dealing with 3 different segments. The question is, which one of these 3 segments pertains to the situations where x is equal to 0? Well, let's find out, shall we? We're looking for situations where x is equal to 0. Well, here in the third segment, x is more than 5, more than or equal to 5. Obviously, that's not what we're dealing with. In the second segment, they tell us that x is between 1 and 5. Well, if x is equal to 0, obviously it's not between 1 and 5. The segment that we're dealing with is this one, the very first one. So this is the relationship that we're looking at. Which means y is equal to x squared minus 2, because x is less than or equal to 1. If x is less than or equal to 1, this is the relationship that pertains to it, and if x is equal to 0, then obviously x is less than or equal to 1. So we substitute 0 in here, we get 0 minus 2 equals to y, which means y is equal to negative 2. There you go, that's it. Now we're going to look at the 5 answer choices and see if there is any answer choice where the graph does not cut the y-axis at negative 2. If it does not cut the y-axis at negative 2, then that's not the answer. We wouldn't know what the answer is, but at least we'll knock out the impossible answers. Do you understand? Let's look at that. I need a lot of room here. I don't know what we can cross out and what we can leave. Let's look at G. Let's look at answer choice G. In answer choice G, we have 1, 2, 3. Remember, we're dealing with this part. We are dealing with this segment here. We are dealing with the first segment right here. How can I highlight it? How can we emphasize it? We are dealing with this graph. We are not dealing with the linear graph. We are dealing with this guy. When x is equal to, or when x is less than or equal to 1, we are dealing with this guy. And since x is equal to 0, we are dealing with this guy. We are dealing with this segment. We're not dealing with linear segment. These are a linear segment. X minus 7 is a linear. It's a straight line thing, and so is 4 minus x. That's a linear segment. We're not dealing with this segment. We're not dealing with this segment. We're dealing with first segment, which means this guy has to cut the y-axis. At negative 2. If you look at this graph, it doesn't even cut the y-axis. It stops right there. That graph doesn't even go to y-axis. That is not the answer. It does not cut this parabola here. Does not cut the y-axis at negative 2. It does go to I don't know if it goes to -1 or -2, but that doesn't matter. It goes to 1 here, but the point is it does not cut the y-axis at -2. That is not the answer. G is not the answer. We don't know what the answer is, but it's not G. Let's go on then. Let's look at J. Let's look at H actually. Let's look at H. Where can we keep track of our inventory? Where can we keep track of our inventory? G, H. How do the answer choices go? G, H, F, F, G, H, J, K. F, G, H, J, and K. What did we just found? We found out that G is not the answer. Let's look at H. In H, if you look at the graph in the answer choice H, if you look at carefully, you will see that it looks something like this. 1, 2. Actually, H is, answer choice H is, it cuts at 0. It cuts at 0. 0 and 2. There you go. This is the graph that is given in H, right here, and cuts the y-axis. It cuts the y-axis as 0. The y-intercept here is 0, 0. We need the y-intercept to be -2. That's not it. That's not the answer. We don't know what the answer is, but it's not H. Let's look at J. In J we have 1, 1, 2, and then 1. There you go. It does cut the y-axis at -2. It does cut y-axis at -2, 0 and -2. But there's a problem. There's a problem with answer choice J. The problem is that in answer choice J, we have a linear segment that goes all the way up to -7. It goes all the way up to -7, and it starts from here. There are two problems with this thing. Two problems is that there's an area here where they overlap. This portion right here, this portion right here, and this portion right here, they overlap. There is no such thing here. There is no overlapping here. These are distinct. When x is less than or equal to 1, when x is less than or equal to 1, it has to be this relationship. When x is between 1 and 5, it has to be this relationship. When x is more than or equal to 5, it has to be this relationship. There is no overlap of the value of x's. As you can clearly see in this area, the value of x's are overlapping. The big problem for us, from our point of view, is that in this answer choice, yes, this graph, the parabola does cut the y-axis as -2, but we have another y-intercept. We have another y-intercept of -7 rather. We have another y-intercept of -7, but our math clearly shows that there is only one y-intercept. When x is equal to 0, only this segment applies. Only this segment applies. This one does not apply. This is only for those people who are plugging in 0 in here. If you plug in 0 here, you're going to get 0 minus the 7. You're going to end up with -7. But why would you put a 0 here? This does not apply. When x is equal to 0, x cannot be between 1 and 5. In order for x to be between 1 and 5, x cannot be equal to 0. So when x is equal to 0, we are not in the second segment. We are in the first segment. When x is equal to 0, we are in the first segment. The second segment does not apply. This is wrong. J is wrong. We do not know what the answer is, but it's not J. The answer is either F or K. Let's look at very quickly the remaining two. Now if you look at the remaining two answer choices, F and K, if you look at the remaining two answer choices, F and K closely, if you pay attention there, and if you look at it closely, you will see that the linear segment, the second and the third segment, the linear segment are identical. This linear segment here and this linear segment here, in F and K, they are identically drawn. They are drawn in exactly the same way. What does it tell us? It tells us that in order for us to figure out what the right answer is, we only have to look at the first segment. Wasting our time with the second and third segment is not going to get us anywhere, because they are depicted in the exact same way in the two answer choices. There is no difference. If you look at them closely, in F and K, they're the same way. So we look at only the first segment. So let's take a look at one more time very quickly here. This is our F and this is our K. It's either F or K. 1, 2. In F we are looking at something like this, and in K we are looking at 1, 2. There we go. It's either that or this. It's either this. It's either this or that. But that's very easy to figure out. All we have to do is plug in. The value of x equal to 1. Value of x equal to 1. In one case, when x is equal to 1, listen carefully. In F, when x is equal to 1, we are told that y is equal to -3. Oh. Is it -3? Let's make sure it's... Yes, it is -3. And in this case, let's rewrite it so we can read it properly. -3. And in this case, when x is equal to 1, y is equal to -1. It's either this or that. It's very simple. All we have to do is go to our expression here, x squared minus 2. Go to this expression, x squared minus 2, and plug in the value of x equal to 1. And see what happens. Right here. Y is equal to x squared minus 2. When x is equal to 1, 1 squared minus 2, 1 squared minus 2 is going to give us -1. Y has to be -1. Y has to be -1 when x is +1. When x is +1, when x is equal to +1, y has to be -1, as we just found here. That tells us that this is wrong, because here when x is 1, y is -3. It's wrong. The answer is K. The answer is K. That's all there was. That's all there is. I'll see you tomorrow, okay? Bye now.